the first thing you have to do is assign oxidation numbers. And there's certain rules that you have to follow that are in the notes and also in the textbook. So the rules are, first one says metal or non-metal in a free state has the oxidation number of 0. So a free state means it's all by itself, it's not attached to anything. Like this is not attached to anything, this is not attached to anything, but these are attached to each other on this side. So this is not a free state, these are both free state, so their oxidation number is 0, and you write that above the symbol. Okay. Next rule in the notes in the textbook says monoatomic ions have the oxidation number equal to its ionic charge. Here we have no ions. If this was an ion, there would be something written right here, either a positive or a negative. If this was an ion, it'd be written here. If this was an ion, it'd be written here. But we have no ions, so that rule doesn't apply to any of these. The next rule says hydrogen atom usually assigned oxidation of a +1. So if we had hydrogen, you would try a +1 first. Number 4 is oxygen usually has a -2, which we don't have oxygen, but if we did, we would try -2 first. Number 5 says molecular compounds, the more electronegative element is assigned the negative oxidation number. Molecular compound. We don't have a molecular compound. To check to see if it's molecular, the first one has to be a non-metal. In this case, it's a metal. The non-metals are on the right side of the stair step. The metals are on the left side of the stair step. Okay. So magnesium here is number 12, so it's on the metal side. These are metals, these are non-metals. Okay. For number 5, molecular compound means it starts with a non-metal, but it starts with magnesium, so it's a metal. So that'd be number 6. Ionic compounds, they have the sum of the oxidation numbers for each has to be equal to 0. So because this is not an ion, there's no charge here, this whole thing has to add together to be 0. So to assign oxidation numbers, to get that to be 0, these two are going to have to cancel each other out. Now the first one is always going to be a positive number. The second one is always going to be a negative number. If we take a look at magnesium on the periodic table, it's in the second column. And these all have an oxidation number of 2. And you can see on this periodic table, the oxidation numbers are right above the symbol. So that little 2 right there, that little 2 right there, that little 2 right there. So magnesium is a +2 individually. But this little 3 means I have 3 magnesiums. So that means 3 times this +2 gives us a total of +6. So we are going to have to cancel that +6 to be totally equal to 0 using this nitrogen. So the nitrogens are negative. What negative number times 2 is going to give us a -6? 2 negative numbers, if you add them together, gives us a -6 altogether. -3 and -3. If you have 2 -3s, you get a total of -6. So we have each nitrogen is going to be a -3, but I have 2 nitrogens, so I have a -3 for the first nitrogen, a -3 for the second nitrogen, totally equals -6, which cancels this +6 to get to 0. So now to figure out the redox part of it, the oxidation and reduction part, you have to figure out from the reactant side of the equation, which is on the left side of the arrow, or the yield sign, what changes by the time it gets to the right side. So right here, magnesium goes from 0 to being individually a +2. So magnesium changed between reactant side and product side. And then nitrogen went from being 0, oxidation number of 0, to being an oxidation of -3. So it also changed from reactant side to product side. Now we have to figure out how it changed. So the magnesium, this 0 means the protons here for magnesium equal the same amount of electrons. And then over here, we have more protons than we do electrons because we have a +2. Protons are positive, and and electrons are negative. And electrons are what change. How many electrons is what changes between both sides? So here we went from protons and electrons being equal. In this case, magnesium is number 12 on the periodic table. It has 12 protons, therefore it has 12 electrons here, because this 0 says they equal each other out. Over here, we still are going to have 12 protons, but this positive 2 means we have 2 more protons than we have electrons. So how many electrons does that mean that we have? 10. So what happened to our electrons from the reactant side to the product side? Did we gain them or did we lose them?
Lose them.
We lost electrons. Now nitrogen is number 7 on the periodic table. The nitrogen, this 0 means the protons and electrons equal each other, so it means we also have 7 electrons. Over here, -3, we still have 7 protons, otherwise it's not nitrogen, but now we have 3 more electrons than protons. So if we had 7 and we have 3 more, how many do we have? 10. So did we gain or lose electrons from the reactant side to the product side?
Gain.
Good. Now, oil rig is the hint that helps me remember. Until I figured that out, this was really hard. But oil rig means oxidation involves lost electrons. So reduction involves gained electrons. So if magnesium lost electrons, did it go through the process of oxidation or the process of reduction? So if nitrogen gained electrons, it went through the process of reduction. Now, oxidation and reduction, or redox, happens simultaneously together. So if something is oxidized, it's also reduced. Or something else has to be reduced, sorry. So if something lost electrons, something else had to gain those electrons. They happen hand in hand. So because magnesium went through the process of oxidation, it caused nitrogen to go through the process of reduction. So if something was oxidized or went through the process of oxidation, it caused the other one to be reduced. Therefore, it is the reducing agent. Agent is caused. So because this went through oxidation, it caused the reducing process. So if this one went through the process of reduction, same thing, it caused the other one to go through oxidation. So this is the oxidizing agent. And that's what you have to be able to figure out to do for chapter 17. That's it.